Good evening. Today we'll move on to the next part. Okay, this is chapter 8. We're talking about measures of dispersion of ungrouped data. So previously, as we have seen before, okay, under this concept of ungrouped data, we've actually looked at a few concepts like the mean, the median, the mode, okay, for a set of ungrouped data. And this comes under statistics, whereby you actually use these quantities to analyze the given situation, right? So today we'll move on to another concept called dispersion. Okay, the word dispersion itself, when you are talking about the dispersion, okay, there are a few things that actually will come to mind. Number one is dispersion is actually associated with scattered. So when you say data are scattered or dispersed, how much is it dispersed? So we want to know how widely are the data scattered. Okay, so is it a wide range or is it a narrow range? Okay, so when you're talking about dispersion, scattered, okay, should come to mind. So that's what we're going to look at. Okay, under dispersion, there are few concepts or quantities that actually explain how far a data is dispersed. Okay, so some of the quantities that we actually can look at is the concept of range. Okay, range is actually defined by the highest value minus the lowest value, or the highest class mark minus the lowest class mark. Okay, so range. Interquartile range, as we have seen before. Okay, interquartile range will involve graph but actually divided into 4 sub-quadrants. Okay, so normally interquartile range is actually a difference between the third quartile and the first quartile. Okay, so that is another we can actually use to measure dispersion. Okay, then you have got the variance. Okay, variance and standard deviation actually tells you how far the difference is between a certain value to its designated mean. Okay, so here we're actually looking at the difference. So these are some of the quantities that we'll actually be looking at, okay, under dispersion of ungrouped data. Okay, so for a simple example, something that we've seen before. Okay, let's say you've got a set of 10 data here, ranging from 112, okay, all this, yeah. Okay, now let's say the question wants you to find the lowest and the highest values. So in this case, the lowest value will be 45, correct? So because if you compare this, the lowest value, so my lowest value here is actually 45, and the highest value, as you can see, is the 150. So now the question wants you to find, okay, determine the range or the difference between these values. So this one will actually be your range. It's actually the highest value minus the lowest value, which is 150 minus 45. That will actually give me 105. Okay, so that's the difference or the range between the values in this table. Okay, now another thing that you have seen before is something called the dot plot. Okay, this is one example of a dot plot. Okay, now what is a dot plot? Okay, a dot plot is actually a statistical chart, okay, whereby it actually contains points plotted using a certain uniform scale. Okay, now each plot here actually represents a value. Okay, so this is a dot plot where you put dots. Okay, a scale is drawn. Normally it's a uniform scale. All right, okay, so example, so let's say we have got two here, one dot plot A and the other one is dot plot B. Okay, now how do you read this? First thing first, what we need to look for is, of course, your range, highest, lowest. Okay, so if you notice here, this is for the first one. Okay, the lowest value that I can actually get from this scale, this is about 16. This is 16, 17, 18, 19, means 10. So that means each box here will represent two of the units. So this is actually 16.5, and here it's about 18.5. Okay, highest, this is my lowest value. Okay, so whereas for this, if you notice here, this is 16.3. The value here is 16, and then you've got 3 boxes, so it's about 16.3, and this is about 18.9. Okay, so if you noticed, just by just looking at it diagrammatically, you can actually see that this range is actually smaller. This range is actually smaller compared to this. Okay, all right. So we will say that this is more widely dispersed compared to this. You can actually see it is actually scattered out bigger compared to this. Okay, so that means now, likewise, if we were to analyze this, okay, so based on the scatter plot, this is smallest, highest value, smallest, and this is the highest value. All right. So for based on the graph just now, so we have got scatter plot A and B. Okay, so if I were to look for the lowest value for scatter plot A just now was 16.5, and the highest was 18.5. Okay, and then for scatter plot B, the lowest value just now was 'this is the largest value for A, the largest value for B. So this is this is 18.5, this is 18.9. Okay, lowest value will be for A, 16.5 and 16.3. Okay, so the difference here is actually 2.0. So here it's about 2.6. Okay, so this is your dispersion. For the first for the first dot plot is 2. For the second dot plot B, it is 2.6. Okay, so the higher dispersion will be dot plot B, because it has got a dispersion or a difference of 2.6. Okay, so this is one chart that we can actually use to statistically look at the level of dispersion, okay, given a set of data. Thank you.